Right, so it's quite likely when you think of generating with water, the first thing that springs to mind is hydroelectric and dams and water wheels and turbines, because that's certainly what I think about. But in the last few years, that's kind of changing. And what they're looking at is water generation with this stuff, damp paper. Now, paper is made of cellulose fibres. It's either chopped up wood or chopped up rags, it's cotton. But the fibres in wood and cotton are cellulose, and cellulose is just a long chain sugar. It's a polymer of sugars, and it has an awful lot of OH groups and O groups sticking off of it, so carboxyl and hydroxyl groups. Now, carboxyl and hydroxyl groups have a curious property that if they get damp, then the hydrogen, the H+, can dissociate from the chain and migrate, leaving behind a negative charge and a mobile positive charge. Then it'll do that against a concentration gradient or against a moisture gradient. So if the paper's more damp on one side and less damp on the other, then you will get this migration of positive charges, leaving it positive one side and negative the other side, in association with generation of an electric current. And that's absolutely fascinating. And it's fascinating an awful lot of people, and an awful lot of research is now going onto this, and they're calling it moisture enabled generation, or MEG. It's difficult to tell whether this is more linked to traditional hydroelectric generation or it's more linked to a battery, because you can start to think of those kind of devices as moisture charging or self-charging batteries, or you can think of them as hydroelectric generators. It's kind of halfway between the two. Now, what's stunning about them is how simple they are to make. You really need nothing at all. You need a piece of paper and a current collector on one side with holes in it so the moisture can get in, and a current collector on the other side with no holes in it. Then when moisture, either from your air or even from just breathing into it, goes into that paper, it will generate a current. And there's a whole range of generation available from sort of 0.1 of a volt up to about 0.9 of a volt per unit that you make. Now, the amount of current isn't huge. The biggest recorded one was 450 micrometers, or more or less half a millimeter, on a 1 centimeter square. Now, for a 1 centimeter square device, that's actually quite stunning, particularly when you think about the price of paper. Then the generation capabilities have got everybody very excited, and they're starting to look at doing things like titanium dioxide nanorods, graphene oxide, forward carbon black. Just all kinds of things have been investigated for this curious hydroelectric generation based on thin films and based on papers. So quite simply, the easiest one I could find was this one. It's called Electric Power Generation Using Paper Materials, and in that paper, which is freely available incidentally, in that paper you can see that these guys just used paper. They used various kinds of paper, and they made origami models out of it, they made masks out of it, they made fans out of it. They even just used a straightforward book and put the electrodes in the book and used a book, and they used slivers of paper 1 centimetre by 1.5 centimetres to do most of their experiments, showing this thing could work. They then linked up 5 of them and ran a calculator off of this 5 square centimetres of paper moistened by a breath. So in order to try this, I've got a rough and ready experiment. I've got 2 bits of aluminium that is usually used for car repair and a piece of paper. We'll put that paper on there and that on there, and I'm going to blow on it and see if I can generate a voltage. And indeed it's generating about 150 millivolts. Now that's from the moisture in my breath. The more the humidity difference, the greater the voltage goes up. The higher the temperature, up to 40 degrees centigrade, the greater the voltage goes up. Another way of increasing the voltage is to do what they did in the paper, and that's to soak this in 1 mole of hydrochloric acid. That increases the number of available protons on there for that transport mechanism, and it makes a significant difference, getting about 0.8, 0.9 of a volt. And they connected 5 together and got something like a milliamp out of it. It was enough for them to be able to use a small calculator out of those 5 things joined together. Anyway, certainly, whether it is a generator or a battery, let's face it, the possibilities here are astounding. I mean, these guys were using 1 square centimetre. Your average house is going to be 2.4 metres high by about 5 metres long times 4 for a single room. So you've got to multiply the output by something like 500,000 so that you would get an idea of what was being generated. So just from the moisture created by people living in a room would be enough, probably, to light that room. That's just amazing. Because you would make the generator, the hydroelectric generator, out of wallpaper and wallpaper paste. I just think there are so many things that could be done with this. Creating a light to light your lamp as you read the book. It just is amazing. This weird sort of gloopy brown-black liquid here is graphene oxide. It's somewhat trivial, if exceedingly dangerous to make, and I've done loads of videos on how to make it because we make our own, basically. What you do is you take some graphite, mix it with an oxidizer like potassium permanganate or sodium nitrate, then you bung it in a whole load of concentrated sulfuric acid, or if you're using the Tour method, a mixture of sulfuric acid and phosphoric acid, stir it around for a bit so you make a nice explosive mixture, keep it at a low temperature, add some hydrogen peroxide and then give it a wash, and hey presto, you'll be left with a ton of this stuff, which is exactly what we do. Now, graphene oxide has been one of those solutions looking for a problem for years. They've tried to do all kinds of things with it, and some more or less successful than the others. But it has been kicking around looking for a job to do, and it looks like the Australians have found something useful to do with it. It's a company called Strategic Elements, who, working with CSIRO and the University of New South Wales, have developed a moisture-based recharging, self-rechargeable battery. Now, the surface of this, there's obviously a huge argument about what that surface actually is. Some people say it's just a bunch of oxidative rubbish. It's more or less agreed that the surface of the graphene is covered by an awful lot of carboxylic and epoxy and hydroxyl groups that attach themselves to the surface of the carbon, creating what we know as graphene oxide. Those groups have a special affinity for water. Now, apparently, and I can believe this, 71% of the Earth is covered in water. Something like 50% of the sun's energy goes into evaporating water from the surface and creating moisture. And there are several things that people are quite good at. I mean, one thing is inventing new things, 2 things being kind to each other, and the 3rd one is sweating a lot. We sweat. We create a lot of moisture, particularly when we're doing something like exercise. And so Strategic Elements decided to put these 2 things together. The unique surface of the graphene oxide and the fact that we sweat a lot and there's an awful lot of moisture to create this battery that would be, or rather is, self-recharging. Now, of course, the performance figures are all over the place, but the company's understandably a little shy about the actual device itself. However, I found this paper. This paper explains the device, and it's written by the guy who heads the research at the Strategic Elements company. And the paper itself was published in 2021, so it's about a year old, something like that. And the device fabrication is simplicity itself. Once you have your go, and you can use Hummers or Tours to make that, you mix the go with a 20 milligrams per milliliter PVA solution, 1:1, and then paint it on a substrate. And the company is using 2 substrates. In the experiment they used FTO glass, but they're also soaking a carbon cloth in this mix, and then they dry it at 50 degrees centigrade until it's dry. Then what you have to do is stick it in a 10% hydrochloric acid solution for 10 minutes, and this creates a whole bunch of functional groups on the top of that GO layer. That GO layer is attached to the collector. The top collector, they used a silver paste to make a top set of electrodes. So very easy to actually make by basically painting on some GO, dipping it in some acid, giving it a wash and painting on some electrodes, and you have yourself a moisture electric generator, or a MEG. And these are supposed to stand right up there with thermoelectric generators and piezoelectric generators, and a square centimetre is reported to give about 0.8 of a volt and 92 microamps around about 2 hours before it needs recharging. That's actually pretty awesome stuff, because that's capable of delivering enough power to run sensors, small electronic devices, and they reckon to run just about every portable consumable that you want to take with you when you're going on a sweaty old jog. So according to the paper, how it works is that when it's dry, graphene oxide doesn't do a lot, but it's hydrophilic, so it will absorb moisture out of the air. When it absorbs that moisture out of the air, it ionizes it or polarizes it, and the functional groups, like the carboxylic acid group for instance, then become mobile in terms of their hydrogen ions, because there is also a moisture gradient between one side and the other. And because there's no hydrogen ions on the dry side, it's all held on the functional side. Simple diffusion means that those hydrogen ions will diffuse through that barrier onto the other side, creating a potential difference. Then when the battery dries, those hydrogen ions migrate back because of the pull of the carboxylic acid group, and it returns to its initial state. Then you end it again, and that process continues on. So it will be self-recharging, which is kind of cool. There is, of course, an awful lot of other research into MEGs, because MEGs are a popular option when it comes to this kind of thing. And it was thought until a few years ago that it wouldn't be possible. But a lot of research has gone into it. However, the voltages and currents were disappointing until this hydrochloric acid treatment. So that dipping it in hydrochloric acid for 10 minutes is key to making this process works, because it creates those mobile functional groups, or rather those groups that have the possibility of mobility. So if you soak it in hydrochloric acid, you create those groups, and then the moisture gradient is sufficient for those hydrogen ions to migrate backwards and forwards across that barrier, creating a difference and generating a current. Because there are still issues, nobody really knows how well this is going to perform in the salty, sweaty condition of somebody's body, but it is looking extremely promising. And in general terms, a moisture electric generator is of course great interest, and it seems that this one, as I say, without the exception of the graphene oxide, which you can buy, is stunningly simple to make. It's one that was one of those kitchen top things that if you have a natural disposition, a willing desire, a paintbrush and some graphene oxide, you're going to be able to make yourself your own moisture generator. And the amount that it generates is by no means trivial. They have done things like run calculators on it. The aim of this apparently is for a market that I didn't even know existed. It's called the electronic skin patch. Never heard of it, but apparently it's worth about $10 billion or so, which just amazes me. But that's the target market for this application, is what they're actually thinking about doing with these moisture electric generators that are self-recharging. The thing that really attracted me about it was the possibility of that kitchen top ability to make such a thing if you wanted to in your own home. Anyway, I've put the paper up, so the link is there. Have a look at it, see what you think of it, because it is stunningly easy to make. And you can buy the Go if you're a bit scared of actually making it. I have done a lot of videos on making Go. I can warn you, it is a dangerous practice, because it is explosive, it is concentrated acids. If you want to go buy the Go, then it's not that expensive. Remember, you're using a very thin layer indeed, so you won't use a lot. So it attracted me because of that reason, but I also like the possibility and this idea of moisture electric generators. So I thought I would share it with you. I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.